Hi, welcome to this Corbettmaths video. In this video, we're going to look at log-log graphs, or sometimes they're called log-log plots. But in this video, we're going to look at log-log graphs, and they particularly come up in the GCSE Further Maths. So in this video, I'm going to go through an example and go through some of the key steps of whenever you answer those questions. So here's a question that I made up. We've got Jessica runs a company that offers limousine hire. So she runs this company that offers limousine hire and a chauffeur as well. And the table shows the cost of 5 journeys in the limousine. So we've got the cost of 5 different journeys. We've got the 11.8 mile journey, cost £179.51, and so on. And we've got here all the distances and the costs of those journeys. And then we're told the relationship is in the form C is equal to AD to the power of n, where A and D are constants. So C is the cost, D is the distance, and A and D are particular constants, so numbers that we perhaps need to find in this question. So this is the relationship between the distance and the cost, and perhaps they use this to work out the cost that each of the customers should pay. And then if we carry on, the question says, part A, verify that a relationship in the form C is equal to AD to the power of n exists by drawing a suitable straight line graph on the grid. So if you've been given information like this, where perhaps it is an exponential relationship, like so, we've got an exponential, here we've got this power. If you draw a log-log graph, which we're going to do, if you draw a log-log graph, then if our exponential relationship exists, you'll find that that log-log graph is a straight line. So whenever we draw this log-log graph in this question for this information, we should hopefully find there's a straight line, a suitable straight line graph on the grid. And then if there's a straight line graph that we've drawn for this log-log graph, then this exponential relationship exists. And then the question asks us to label the axes clearly, which we will do. And we're also asked to show the values used to correct the 3 decimal places in the table. So quite often whenever you're answering these questions, perhaps on the GCSE Further Maths, there's 2 extra columns there for you. So I've set that out here in my question where there's these 2 extra columns, and we've got to fill in and show the values in this table. So let's start by looking at this relationship. Let's look at this relationship C is equal to D to the power of n. So what I'm going to do is I'm going to take the logs of both sides of this relationship. So I'm going to take the log of the left hand side and the log of the right hand side. Then I'm going to use the laws of logarithms to rearrange the right hand side, and we'll actually see we get something that is in the form of y equals mx plus c. So let's take the logs of both sides. So if we take the log of the left hand side, we're going to get log c, and then if we take the log of the right hand side, we're going to get log of AD to the power of n. Now if we have a look at this log AD to the power of n, log AD to the power of n, well, if we think back to our laws of logarithms, log A plus log B is equal to log AB. So if we add 2 logs together, we can multiply the A and the B and it'll be the log of AB. So here what we can actually do is split it up. If we have log AB, we could split it up into log A plus log B. So if we have a look at this right hand side, we've got log of A times D to the power of n. So let's split this up. So we'd have log C on the left hand side still, and on the right hand side we've got A times D to the power of n. So if we split that up, we'd have log A plus log D to the power of n, just splitting up that right hand side. Okay, now if we have a look here, we've got log D to the power of n. Now think back to our third law of logarithms. If you've got a power, you can bring it down. So we'd have log C is equal to log A plus, and then bringing the power down, n times log D. And then finally, I'm going to swap these around. So I'm going to write log C is equal to n log D plus log A. Now if we have a look here, we've got log C is equal to n log D plus log A. Now remember that A and n are constants, they're just numbers. So if we work out log A, that'll just give us a number, and n's just a number there as well. So this is in a similar form to y equals mx plus c. We've got our variables y and x, or log c and log d, and we've got our numbers, our constants, our m and c. Okay, so we're going to draw a log-log graph, and what that means is we're going to do log of the distance and the log of the cost. So along the x-axis will be the log of the distance, or log d, and going up vertically will be the log of the cost. So we need to work out log d, so log d, and we also need to work out log c. So to fill in this column for the log of d, so we're going to work out the log of these values, so log the base 10 of these values, and that'll be then log d. And then in terms of log c, we'll work out the log of the costs, so we'll do log to base 10 of each of these costs. So let's do that. So on our calculator, let's type in log 11.8, and when we do the log of 11.8 in our calculator, we get an answer of 1.0718882007, and so on. Now the question asks us to give our values to 3 decimal places, so what we're going to do is we're going to round that to 3 decimal places. So that'll be 1.07, and then we've got 1 8, so we're going to round up to 2, so it's going to be 1.072. So we've just worked out the log of 11.8. We're now going to do the log of 20.6. And that's equal to 1.31386 and so on. And we need to give our answer to 3 decimal places, so that'll be 1 point, and then we've got 3, 1, and then we've got 3, 8, so we're going to round up, so it'll be 4, and so on. So then we'll do the log of 50, the log of 85, and the log of 203, and we'll put those in here. And then in terms of this column, we'll do the log of 179.51, the log of 271.12, and so on. And whenever you do that and round all your answers to 3 decimal places, you should end up with a table that looks like this. So it'll look like this, where we've got our values for the log of the distances and the log of the costs. And that's it. So we've filled in our table. So we're going to draw this graph, and it's hopefully going to be a straight line graph. We've got log D going across horizontally and log C going up vertically. Now, whenever you're doing these GCSE Further Maths questions, the axes will be there, and you then either have to, you might need to do the scale and put the scale on the axes, or sometimes if you're lucky it's done for you, and then that's fantastic. You now plot these points on that graph. But if they haven't been labelled for you, here we're going to cross horizontally from 1.072 to 2.307. So I would perhaps think of, well, I need my scale to go from 1 to 2.4, and that would cover us horizontally. And then vertically, we need to go perhaps from 2.2 up to 3.2. So then I'd make sure that vertically we'd cover those numbers. So here's a set of axes. So this one actually perhaps was given to you, where you've got cross horizontally, going from 1 to 2.4, and gone up vertically from 2.2 to 3.2. So let's label them. So remember, we've got going across horizontally, log D. So let's write log D here. So log D going across horizontally, and the log of C, the log of the cost, was gone up vertically, log C. So we've got log D going across horizontally and log C going up vertically. Now we just need to plot our points. So let's get our table. So we've got log D and log C. And then here's our table, these are our points. So our first one was 1.072 and 2.254. So we're going to go 1.072 across. So let's have a look at our scale. We've got 1, we've got then this would be 1.1, 1.2, 1.3, 1.4, and so on. So if this is 1.1 here, 1.1 here, we would then be going up in 0.02. So this would be 1.02, 1.04, 1.06, 1.08, and 1.1. Now we want to do 1.07, there's roughly 1.07. Obviously you're not going to be able to plot these exactly. So 1.07, we've got here 1.02, 1.04, 1.06, 1.08, so 1.07 will be in the middle there. So we're going to do roughly in the middle. And then we need to go up to height of 2.254. So 2.254. So let's see what the scale is going up vertically. So here we've got 2.2. This would be then 2.3. So then this would be 2.22, 2.24, 2.26, 2.28, and 2.3, and so on. So we're going up in 0.02s as well vertically. So we want to go up to 2.254, so roughly 2.25. So 2.22 would be there. 2.24 would be there, 2.25 would be in the middle of 2.24 and 2.26, so it's going to be roughly there. So that's going to be where our first point will be here. Okay, our next point, 1.314 and 2.433, so roughly 1.3 and 2.4, that's what I'm going to plot here. So 1.314, so 1.3 would be there, 1.32 would be there, so 1.31 would be in the middle, so it's going to be roughly in the middle there. Then we're going to go up to 2.43, so 2.4 is here, 2.42 would be there, 2.44 would be there, so 2.43 would be in the middle there somewhere. So that's going to be our next point there. Okay, so we've plotted that point. Our next one would be roughly 1.7, so 1.7 would be there, that line. It's 1.699, so that's roughly 1.7. And then 2.718, so I'm going to do 2.72, roughly 2.72. So we're going to go up to 2.6, 2.7 there, 2.72 would be there, so that's the point 2.72, done. Our next one, 1.93 and 2.89, so 1.93, so 1.9 will be there, 1.92, 1.93 is in the middle there. And then in terms of the height, 2.89, so 2.8's here, so 2.82, 2.84, 2.86, 2.88, and then 2.89 will be just before that one, so it's then going to be there. So that's then our next point, that's that one done. Okay, our next one, we've got 2.307, so roughly 2.31, so it's going to be there just after the 2.3. That's 2.3, 2.32, so 2.31 will be in the middle. And then we've got a height of 3.168, so roughly 3.17. So we're going to go up 3.12, 3.14, 3.16, 3.18, so 3.17 we just beneath that, so that'll be there. And so then there are points. Let's actually have a look at the ones I've done earlier. So there's our points. So they would look something like that. And if you notice, those points are in a straight line. And actually, if you get a ruler and pencil, you can draw a straight line through those points. And now here, this one actually does go through this little bit here. It's not the origin because we're going 1 across and 2.2 up. The line doesn't have to go through there. Obviously, the points could go that way. But as you can see here, the points are in a straight line. So if we go back to our question, the question says, verify that a relationship in the form c is equal to AD to the power of n exists by drawing a suitable straight line graph on the grid. So we've drawn the straight line graph of log d against log c. So log d going across horizontally and log c going up vertically. That's our log graph. And we've labelled the axes. So we had log d going across horizontally and log c going up vertically. And then we also showed the values that we used in the table, correct to 3 decimal places. And then we plotted our points. It was a nice straight line and we drew a nice straight line through them. And because we drew a nice straight line through those points, then we know it's in the form y equals mx plus c. So that means it is log c is equal to n log d plus log a. So it's in that form. And remember, that was what we got whenever we took our exponential and we took the logs of both sides. So that means that this relationship does exist, and we've just drawn the graph of log c equals n log d plus log a. So that line we've drawn was in the form of log c is equal to n log d plus log a. So it's that y equals mx plus c. So that's part A done. And quite often with these log graph questions, that part A is quite similar. Whenever we look at these GCSE Further Maths papers, it's quite similar in terms of the question that you're asked. Let's have a look at then at part B. So part B says, hence find the values of A and N, the values of those two constants. So in part A, we've shown that this relationship exists. Now we need to find the values of A and N. So if we go back, we've just drawn the graph of log c equals n log d plus log a. So the graph we've drawn, this linear graph, is the graph of log c equals n log d plus log a. Now we want to find the values of n and a. And as we've seen, it's in the form y equals mx plus c. So that means the gradient will be equal to n. So if we work out the gradient of the line, that's going to be equal to n. So this part n, we can find an approximation for it by working out the gradient of the line. And then to find the value of a, I would go back to the relationship, which is c equals AD to the power of n. We've worked out n, which is the gradient of the line. If you put in a pair of values for c and d, and we'll know what n is, we can then work out what a is. So that's how I'd find the value of a. So that's the approach that I would use. Now there is another approach to find the value for a, and that is to consider where we have that log c equals n log d plus log a, and that's in the form of y equals mx plus c. You'll see that here the log a is the y-intercept, the plus c. So if we find what the y-intercept is, then you could then find out what a is, but I would use that first approach of actually just using the value of n that we calculate, and then also using a pair of values for c and d, and then work out the value for a. So let's do that. Let's start off by finding the gradient of the line, because if we can find the gradient of the line, that's going to be equal to n. So let's do that now. So let's work out the gradient of this line. So the gradient m is found by rise over run. So we would draw a little triangle and do rise over run. Or we could use the formula that m, the gradient, is equal to y2 minus y1 divided by x2 minus x1, where x1, y1 and x2, y2 are points on the line. And this is just really rise over run, because y2 minus y1 would be the difference in the two heights, that's the rise, and x2 minus x1 is the difference in the horizontal position, so the run. So here, if we choose 2 points, I'm going to choose, because all the points are on the line nicely, I'm going to choose the first one, I'm going to choose the last one. So I'm going to choose these points here, this one here, and this one here. And I could draw a little triangle if I wanted to, or I could just look at the points, and here the gradient will be equal to y2 minus y1. So let's look at the heights. The height of this point, well, this point here was 2.307 across and 3.168 up. So the height of this point will be 3.168. And then that's going to be then subtract the height of the other point, where we're using this point here, and the height of this point was equal to 2.254, so subtract 2.254. If you had drawn a little right angle triangle, you would have taken the height of this one and taken away the height of that one, and then that's what we're doing here, divided by, and then we're going to take away the horizontal positions. So the horizontal position of this point here, x2, is equal to 2.307, so 2.307, subtract the horizontal horizontal position of this point, which is 1.072. And whenever we work this out, we're going to find the gradient of the line. So let's do that. So let's type this into our calculator and see what we get. And whenever we work that out, we get that's equal to 0.7400809717. And I'm going to round this, and I'm going to round it, well, I'm going to round it to 2 decimal places here because we've got our 7400. I'm just going to round this to 2 decimal places, so that'll be equal to 0.74. So the gradient of this line is 0.74. So that's fantastic. We found the gradient of the line, m, is equal to 0.74. So that means that n is equal to 0.74. So n is equal to 0.74. So that's fantastic. And just a reminder, whenever we're doing these log-log graph questions, if you want to find the power, that constant is the power in the relationship, if you find the gradient of that log-log graph that you draw, that'll be the power. So we've now found the value of n, we now also need to find the value of a. So what I'm going to do is I'm going to go back up to the relationship, which is in the form c equals ad to the power of n. And we've worked out what n is, and we can use a pair of values from our table for c and d, and then we can work out what a is. So I'm just going to get rid of this part now, so let's just rub this part out a moment. And I've just put a copy of the table here where we've got our values for d and c. We've also got log d and log c, but we just need to focus on the values of c and d. And we've got our value for n. Now actually, whenever we're working out the value for a, I'm not going to use the rounded version for n. I'm actually just going to go back and write down what was on my calculator display, which is 0.740080917. So that's what's on my calculator display. So I'm using that rather than the rounded version. It probably wouldn't make much of a difference here because we've got 0.7400 and so on. But I'm just going to use that unrounded version because it'll give me a more accurate value for a. Okay, so if we go back up to our relationship, we had c is equal to ad to the power of n. And instead of writing down n, I'm going to put in the value for n, which is 0.74008, and then just some dots to show that that number carries on. Okay, so we've got the c equals ad to the power of 0.74008, and so on. Now what I'm going to do is I'm going to choose a pair of values for c and d. So I'm just going to go up to the table and I'm going to choose the first pair of values. So d is equal to 11.8 and c is equal to 179.51. So let's substitute those values into this. So instead of c, we've got 179.51 is equal to a multiplied by d, which is 11.8 to the power of 0.74008, and so on. Okay, this is fantastic. We now just need to work out what a is, and this is a little equation here. So I'm going to work out what 11.8 to the power of this is. Now this is already on my calculator display, so that's quite nice. I can just type in 11.8 to the power of answer, and then whenever I press equals, I get that's equal to. So we've still got 179.51 is equal to a multiplied by, and when we work this part out, I've got that's equal to 6.212687, and so on. And now we want to work out what a is, so we don't want this multiplied by 6.212 and so on. So we're going to divide both sides of the equation by 6.212 and so on. So let's do that. So we're going to divide the left hand side by 6.212 and so on, and divide the right hand side by 6.212 and so on. On the right hand side, we'll just be left with a, because we're dividing by the 6.212 and so on to get rid of that multiply by it, so we'll just be left with the a. And on the right hand side, if we do 179.51 divided by answer, we get that's equal to 28.894 and so on. And that's it. So we've worked out our value for a. So we've got the value for a and we've got the value for n. So a was equal to 28.89 and n was equal to 0.74. So that means our relationship is c is equal to a, which is 28.89, multiplied by d, so d, I'm just going to make sure it's a d, to the power of n, which is 0.74. So we've now found the relationship, which is fantastic. Okay, let's look at our next part. Our next part then says a customer hires a limousine for a journey of 100 miles. Find the cost of hiring the limousine. So we've got the relationship. We know that the cost is equal to 28.89 multiplied by d to the power of 0.74. And we've been asked to find the cost of a journey that lasts 100 miles. So the distance is equal to 100. So that means we can substitute in 100 for the value of d. So that means the cost would be equal to 28.89 multiplied by 100 to the power of 0.74. And if we work this out in our calculator, we'll find the cost of that journey. So 28.89 multiplied by 100 to the power of 0.74. And that's equal to 872.464052. And if we round that, let's round that to 2 decimal places, because obviously we're dealing with a cost here, that'd be equal to £872.46. And that's it. So that would be the cost of hiring the limousine for a 100-mile journey. Okay, and let's have a look at our last part. Our last part says a customer pays £400 for the limousine hire. Find the distance of the journey. So we want to find the distance this time. So we know the cost is equal to £400. So we've got cost is equal to 28.89 multiplied by d to the power of 0.74. We know the cost is £400. So we've got £400 is equal to 28.89 multiplied by d to the power of 0.74. Now we want to figure out what d is here. So what we're going to do is we're going to divide both sides by 28.89. So divide by 28.89, divide by 28.89. So the left hand side, whenever we do 400 divided by 28.89, we get an answer of 13.84562132. And that's equal to, on the right hand side, we've divided by 28.89 to get rid of the 28.89. So we're just left with d to the power of 0.74. I'm just going to turn this around, that d, the distance to the power of 0.74, is equal to 13.84562132. And now we want to solve this to figure out what d is, the distance of the journey. So at this point, what we can do is we can use a couple of approaches. Okay, so one approach is to look at the equation. And just before I carry on, I just want to mention something. I just want to mention that if you've got a number, such as 2, and you multiply by its reciprocal, so remember 2 is 2 over 1, and if you take the reciprocal of that, you get that's equal to half. And that a number multiplied by its reciprocal is always equal to 1. So for instance, if we had 2/3, and you multiply that by 3/2, that's equal to 6 over 6, which is 1. So if you multiply a number by its reciprocal, you get that's equal to 1. And I just wanted to show you that before I carry on and show you how we would solve an equation like this. Okay, so let's get rid of that. So number multiplied by its reciprocal is equal to 1. So here we've got d to the power of 0.74 equals 13.84 and so on. So if we wanted to solve an equation like this, we would want to get the letter on its own. So we want to get the d on its own. And the d on its own would be d, and I suppose that's d to the power of 1. So we want to figure out what power we would raise both sides of this equation by, so that instead of it being d to the power of 0.74, we get d to the power of 1. And to do that, what we're going to do is we're going to think, well, what do we multiply? Remember the laws of indices, that if we had x to the power of a, and we raise that to the power of b, you get that's equal to, times the powers together, that'll be x to the power of ab. So whenever we raise both sides of this equation to a particular power, we'd have d to the power of 0.74, and then in brackets, and then we're going to have a certain power, and then whenever we multiply those two powers together, we want it to be an answer of 1. And remember that a number multiplied by its reciprocal is always equal to 1. So that means that our power will be 1 over 0.74. I'm just putting 1 over whatever the power is to 0.74, because 1 over 0.74 would be the reciprocal of 0.74. And if you multiply these two together, the 0.74 and 1 over 0.74, you're going to get 0.74 over 0.74, and that's equal to 1. So what I've done here is I've raised the left-hand side of the equation to the power of 1 over whatever the power was, so 0.74. So what we're going to do is we're going to have to do the same to the right-hand side of the equation, where we had 13.84562132, and we'd have to raise that to the same power, so it'll also be raised to the power of 1 over 0.74. So that would give us d to the power of 1, or I could just get rid of that 1 and make it just d here. And then on the right hand side of the equation, we've got that's equal to 13.84562132 to the power of 1 over 0.74. Now, a lot of people would just go from this step to this step, that if you had d to the power of 0.74 equals 13.8456 and so on, where you just write that d equals 13.84 and so on to the power of 1 over whatever the power was. And then you could just solve that on your calculator. You could just type that into your calculator, and when you do that, you get an answer of 34.8589355 and so on. And that's it. We've found d, the distance of the journey. So if a customer pays £400 for a limousine hire, the distance of the journey would be 34.86 miles to 2 decimal places. And that's it. So in this question, we wrote down the relationship that C was equal to 28.89 times D to the power of 0.74. We substituted in 400 for the cost, C, and we got that 400 was equal to 28.89 multiplied by D to the power of 0.74. We divided both sides of the equation by 28.89, and we got that D to the power of 0.74 equals 13.84562132, and so on. And then, whenever we solved this equation, what we done was we then just said that D was equal to 13.84562132 to the power of 1 over 0.74, if you just do 1 over. And the reason is that if you raise both sides of that equation to the power of 1 over 0.74, that would just leave you with D on the left-hand side of the equation. And then you'd solve it that way. So that's one way to do it. Now, if I was actually solving this question, the approach that I would use would be, whenever I get to the point that D to the power of 0.74 equals 13.84562132, and so on, the approach that I would use is actually to take the logs of both sides of that equation. So I would write down that log D to the power of 0.74 is equal to log 13.84562132. Then what I would do is, using our laws of logarithms, I'd bring that power down to get the 0.74 log D is equal to log of 13.84562132, and so on. Then we want to solve this, so we want to get the D on its own. So let's get rid of this multiply by 0.74. So I'm going to divide both sides of the equation by 0.74. So divide by 0.74 and divide by 0.74. On the left hand side, we'll be left with log D, and on the right hand side, 1.542314121. And we're nearly there. We just need to find out what D is now. So here we've got the log of D. So that's log to base 10 of D is equal to 1.54, and so on. So here we've got the base, the power, and the answer. So the base, 10, the power, 1.5423, and so on. That's equal to D. So if we work out what 10 to the power of 1.5423 and so on is, we're going to find out what D is. So on my calculator, I'm just going to do 10 to the power of answer, and that's equal to, D is equal to 34.8589, and so on. And again, we could round that to 2 decimal places, and that would be 34.86 miles. And that's it. And that's how I would approach that question. I would again go to the relationship, substitute in 400, get to the point where we've got D to the power of 0.74 equals 13.84, and so on. And then I would take the logs of both sides, bring down the power, and then just work out what the D is. And that's it. So in this video, we've been looking at log-log graphs. We've looked at these exponential relationships and how we could draw a log-log graph. And if that's a straight line, then we know that the exponential relationship exists. And these questions are very common on the GCSE Further Maths paper, where you'll be given two variables and you'll be asked to verify that this exponential relationship exists. And then what you'll do is take the relationship, and then what you would do is you take the logs of both sides of that relationship and then use your laws of logarithms to rearrange it into a form that looks similar to y equals mx plus c. And then you'll then go back to your table, you'll then take the logs of both of the variables and round them to how many decimal places you're asked to round them to, and then you'd plot them on a set of axes. And then whenever you plot them, hopefully you'll get a straight line graph. And you can work out the gradient of that straight line, and that would be your power. And also remember that you've already got your equation in the form y equals mx plus c. So if you work out the gradient, you'll see that's equal to the power. And then to find our value for a, we go back up to the relationship, which is c equals a multiplied by d to the power of n. We substitute the value for n that we've just calculated, the power, and we also put in a pair of values for c and d. And then we can work out the value for a. And then once you've found what the values are, your constants, then you can then use that relationship to then work out other values. So use that relationship to work out other values, and that's it. So these questions are very common, these log-log graph questions on that GCSE Further Maths. I really hope you found this video useful. If you have found it useful, please like it and subscribe to the YouTube channel. Thank you. Cheers. Bye.